All right, so good evening, everyone. I'm Jason McCormick, N80I, and I pulled my partner in crime in all these repeaters, John N8CD, and he's going to talk through a couple of the slides as well.
Hi, good evening, guys.
And what we're going to discuss tonight is digital and network connected repeaters. So we had been asked to come talk about some of the work that we've been doing, some of them with the Silver Creek Club's repeaters, some of them with repeaters that we operate, and we've been working with some of the Wayne Amateur Radio guys down in Worcester on repeaters. So this is kind of we're going to kind of go through a 10,000 foot view of what we're doing with digital and network connected repeaters. And please feel free to make this interactive. If you have a question, go ahead and pop off mute and go ahead and ask us. Don't hold questions to the end because we're going to kind of blow through some of these topics. So part of the question that we get asked about this, and this comes up, is what's the point? You know, repeater use is dropping everywhere and has been for, you know, more than a decade, right? And I think everyone knows, you know, at least some of the repeaters, you know, even in this area are 99% idle. As a matter of fact, a while back, we did a traffic study on Sarah's 70 centimeter machine, 442.275. And aside for the 1/2 hour roundtable net, there was I think it was 1 minute and 20 seconds of average key up time in any given week, which is discouraging if you're used to, you know, if you like to operate repeaters or use repeaters. So the question is why care about repeaters? Why care about network repeaters? Why care about digital repeaters? Why discuss this topic now? So there's a couple points with this that we think are important. The first is that no new hams or techs, and that for practical purposes, techs are limited to FM. Now, obviously, that's not true. You know, there's a few areas in the HF bands they have access to. They can obviously do SSB and things like that in, you know, in the VHF and UHF and up ranges. And those are all good activities to encourage. But practically speaking, there's not many people who are doing those activities. And most people, you know, who are getting into amateur radio have bought a, you know, a lower priced HT and really want to just get on the air. So for most practical purposes, that means, you know, that means a repeater of some kind. Obviously, repeaters have largely been replaced by cell phones and the internet. And we think that designs of repeater systems have to follow that accordingly. And we'll get into what that means here in a few minutes. Another big issue that I think that people are really starting to see now is that a lot of previously accessible high-profile sites, such as TV towers, community public safety towers, tall buildings in cities where they have them, those are really going away. TV towers are kicking off repeater owners, and the reason for that is there's new engineering load requirements for these towers. It's not that the owners of these towers don't want hams on there. It's that they can't, based on the engineering studies, the changes in the engineering requirements for tower loads. Another big one is that the statewide radio systems are replacing local sites and systems. So a lot of times hams would help out with the local police or fire, and they'd get some space on a tower or water tower or the courthouse downtown, something like that. But really with Ohio Marks and now with FirstNet, those systems are largely going away. And with that, amateurs are losing access to the sites where those systems used to be housed. Another issue is that new city and county managers are risk averse in today's legal climate. I mean, years ago, you could get away with a handshake deal to put up an antenna on a building or, you know, on a tower or water tower somewhere. But unless those relationships have been maintained for a long period of time, you know, and you're active with those relationships, the new city managers are not interested in continuing those relationships because they're worried about the legal climate that those things bring into them. And then finally, with the development of the 5G cell stuff, you know, buildings with reasonably high profiles, they want the rental income from the cell providers. You know, their high building that was previously not particularly interesting to most people other than maybe some hams is now hot property to put up the 5G microcell sites. So those are some of the things that kind of go into why we're looking at this. Another one is, I think everyone's aware of, obviously, the big influx of the DMR radios. And the reason for that is with the Chinese knockoff radios, and I'm not saying that to be disparaging of the radios themselves, it's just this is the marketplace we live in. You know, there's a lot of land mobile chips out there that are being put into the millions and millions of land mobile DMR type radios that are being pumped out. And obviously that's going to trickle into the ham world, which it has. And another thing is, obviously, there's a lot of people who are, you know, devoted to ICOM or Yaesu radios. You know, a lot of the ICOM radios have D-Star. Most of the Yaesu radios have some form of Wires X. But they've never really used those capabilities because there haven't been repeaters to support those. ICOM repeaters were very, and still are, very expensive. And the Yaesu AMS repeaters, the DR1X especially, while cheap, were not particularly good repeaters. So in summary, you know, and this is kind of the kickoff point with this, is the amateur radio community needs to shift its thinking on repeaters. And we'll go into kind of what we think that means. But are there any questions on kind of that intro material there? All right, so some things that repeaters are not and some things that repeaters are. So repeaters are not going to win back users that left for mobile cell. You know, that battle was lost 15 years ago, and I don't think most people think that's coming back today. You hear the occasional lament on how people aren't around anymore. But realistically, you know, the heyday of the repeater as the local mobile communications solution is over. The repeaters themselves are not going to attract youth and those who are interested in ham radio from the maker community with just standalone FM, and by that I mean a single FM repeater that just does FM back and forth. Repeaters are not going to save the world by their mere existence. Repeaters definitely have a place in the emergency, in the emergency response, emergency management area. But they're a tool in the toolbox. Their mere existence isn't going to necessarily do anything. And there's definitely not a monolithic. They're definitely not a monolithic service anymore. That there was a one true way. For many years, an FM analog repeater was an FM analog repeater, and you used it one way. And when you went somewhere else, the other repeater worked pretty much exactly the same way, except for special. Special DTMF commands to do the calling or, specific commands, things like that. But in general, a repeater worked like a repeater. So what repeaters can be are unique ways to deliver communications with RF sort of as the last mile, so to speak. Connecting virtual communities by topic or interest. There's a big movement among the different digital modes to connect particular communities of interest. I follow, I don't know if people have heard, there's a podcast called Ham Radio Workbench that's really, sort of a technical deep dive into some of the electronics aspects of amateur radio. And a lot of the people that follow that podcast hang out on a particular DMR talk group. And there's many examples of that. That's just one example. It should be an experimental playground, and it should consciously be one. Something that John and I hear a lot with the repeaters we've deployed is, I don't want to break things. You're not going to break things. The systems are there to be used, to be enjoyed, for people to experiment, figure out how your radio works to connect to ALLSTAR or System Fusion or DMR or D-Star, whatever you want to do. Be open about experimentation. Make sure that people are aware of the fact that they can't break it and they're welcome to use it. Obviously, that doesn't open the door for unlimited abuse, but within reasonable behavior, within reasonable behavior, make sure that you're encouraging the use. And obviously, repeaters are a labor of love. The people who maintain them spend a lot of time tinkering and fiddling with them, and they're definitely something to be enjoyed. The people who want to build them enjoy doing so and want to continue doing that. So the strategy that we've been working on, and we think is a good one for others to possibly duplicate or join what we're doing, is to develop and deploy repeaters that are network connected and work well and are stable. Don't abandon analog FM. We want to enhance analog FM, and we'll talk about what that means in a minute. Deploy repeater systems that are complementary and that they interconnect. What this means going forward, like we were talking about with some of the loss of sites, is probably more repeaters at lower profiles to fill coverage gaps. Use the existing low and mid-profile sites effectively rather than sort of leaving them unused orphans. And we want to have the capability and capacity to support others losing a site. I think a lot of people are familiar that a number of hams lost access to the PBS tower, and I'm forgetting the call sign of that radio station over there in Copley, but that took out 3 repeaters when the access to that site went away. Fortunately, all 2 of those were able to find a new home, and the third one, I believe, was just turned off. But as other people lose sites, people who can, they may be able to pick up some of the capacity if those sites were being used.
Pardon me?
I'm sorry, was there a question there?
Yeah, that third repeater, just as an update for everybody, it was turned off, but he's still looking for another site.
Okay.
That was Bob Warner's machine. Thank you.
Yep. We want to consciously provide a space for learning and development. Play with the modes, play with the ideas, talk to the people who are running the machines for new ideas, nets to net connect to, things to do. Provide a space for people to learn and grow. Lower investment costs. Deploy using less expensive equipment. We're going to go through some of the repeaters we've built out of some pretty low-cost parts that work pretty well. The need is not necessarily there to plunk down a couple grand per repeater just to get something on the air. And where possible, operate in situations without internet. Obviously, network connected repeaters are desirable, and internet linking really brings a lot of value to things. But when you can, don't build yourself into an infrastructure corner that relies solely on an internet connection. And we'll kind of go through what we've been doing there. So are there any questions on any of that? Any thoughts on the strategy, or any, want to clarify anything? All right, well, I'm going to turn it over to John, and I'm going to let him talk through some of the repeaters that kind of make up the strategy that we've been discussing here.
Yeah, thanks, Jason. So we've been working, Jason and I have worked hand in hand along with quite a few other people, some folks in the Sarah Club, Marty, N8XPK. A lot of you are probably know Marty well. The folks down in the Worcester Club have had a lot to do with this too recently. So I'll go through a list of some of the ones we've had a hand in, and we'll dig into a few details to show you what we've built. The Sarah 14739 repeater, that's a traditional box there in Doylestown, uses a Bridgecom repeater. And then we replaced the repeater controller with Raspberry Pi. Geez, I guess maybe 3 years ago, something like that. It was a while ago now. The original controller was an RLC, you know, a real nice high dollar controller, and it took a lightning strike and crapped out on us. So we ended up, instead of buying another one, replaced it with a Pi and picked up networking while we did it. So we'll get into that here in a minute. At that same site, we've got the UHF repeater that Jason mentioned earlier that didn't have a lot of use. That's been replaced with a new unit that's also a Raspberry Pi, and that one is running in digital mode. Multi-mode, it does D-Star, Fusion, P25, and DMR. We've got another small repeater. It's kind of a medium coverage site. It's in Rittman. It's a similar setup, and it's a couple of Radius radios. KE8LDH, that's a repeater that's running up on Akron Spring Hill site. So that's co-located with 444.2 and 147.135 there at Marty's site. LDG, that's a repeater that's running out of my house here in Rittman. So I live up pretty high on a hill, so it's kind of a medium profile machine. One of the recent addition, we've added the Worcester W8WOO UHF repeater. They had a similar condition with a lightly used UHF repeater. That's a Yaesu DR1X, and that's now running on a Raspberry Pi and also supports multi-mode digital. We've connected, if you've ever listened to the 6 Meter Sunday Night Net, Marty's 5317 is also networked on ALLSTAR now. That's through this network. Marty's 444.2 and 1292.2 machines, those are also Raspberry Pi linked with ALLSTAR, and we'll get into some of that in a minute. Just recently, we've helped get the Worcester 147.2.1 machine on. That now has ALLSTAR capability with SCOM controller and has Echolink built into it too. And then finally, we're just in the final stages of a 685 machine down here at the bottom of the list to go online in Rittman. So those are the ones that Jason and I have had a hand in, and lots of other folks too here just in the last, I don't know, couple of years for the most part. So I'll give you a quick preview of some of the gear. You know, here's a couple of repeaters. The KE8LDH up on Spring Hill is here on the left. What you're looking at is at the top of the left picture is a set of duplexers. The bottom is an old Yaesu VXR 5000 repeater. The thing that's easily 20 years old, maybe 30. I don't know. It's been around for quite a while. It's an old analog repeater. And then we've interfaced that to the Raspberry Pi that's sitting there in the middle to turn it into a multi-mode digital machine. To the right is an ALLSTAR repeater that's on 1292.2. That's also at Spring Hill. That's an analog machine, but it's interlinked with ALLSTAR as well, and there's a Raspberry Pi sitting in the middle of that. A few of the others, so LDG. This is the one that's located at my house, a couple of Motorola Radiuses and a Raspberry Pi. The 442.375 machine there, it's also a couple of Radiuses. Those have worked out real well for digital conversions. And as you can see, you know, most of these things, there's at most a couple $100 worth of parts in all those machines we've looked at here so far. Then on the bigger scale, if you go over to the right, this is Sarah's rack. And it's been updated a little bit since this picture, but you get the general idea. It's a couple of fairly traditional repeaters, a 2 meter and UHF machine. One of them is ALLSTAR and one of them is analog. So it gives you a little feel for the ones we've worked on here in the last couple of years. And Jason, you want to talk a little about the connectivity?
Yeah, so all of the sites, with the exception of the Worcester site that we were just talking about, are all connected with commercial 5 gigahertz Wi-Fi. So we have dishes at all of those locations, and we're running a full dual stack IP network to all of those locations. One of the questions we do get asked is, why don't we use Hamnet or RDEN or some of the HSSM mesh technologies? And really the answer to that is, that the no encryption and no commercial usage restrictions are pretty limiting. We do help out some of the site owners that we are at with some of their technology issues. So we don't want to be limited to something like Arden where we can't throw a link up to help out one of the site owners who's giving us some space. And there's really no advantage to this use case. The 5 gigahertz commercial gear works great. In its native, we don't have to replace any of the firmware. And, obviously with a public type network, we do want to have some level of encryption to control access to all of the services.
Yeah, Jason, I'll just throw in too, another problem with the encryption is that even if you don't want to encrypt things these days, they are. So for example, if you build a Raspberry Pi, by default, the way to get into that is SSH, which is encrypted. And you can change that to use Telnet or some unencrypted protocol, but at the end of the day, now you're changing things that when you do an upgrade, you're going to have a hard time keeping up with that without going back and reverting things. So, we can SSH into all of our Raspberry Pis, even the remote ones, and it's all legal because it's an encrypted channel, but it's not going over a ham radio network to get to the device. So that's really freed up a lot of what we're doing, and management of the routers at each site, and even the dishes themselves, and everything that's in there uses some sort of encrypted interface by default out of the box, and we can just turn those on when it's a commercial network. Yeah, go ahead, Jason.
Yep. So what we've done is there's a project that's been around since the 80s that's called AMPERNET. And really what it was is it was an IP address grab way back in the 80s to be used for ham radio. We have a couple of allocation blocks, which means if you've ever had to fool around with port forwarding your EchoLink or your ALLSTAR or any of your applications to make it work, we've avoided all of those issues with using 44net IP space. So all of our addresses appear on the public internet. So we don't have to go to any port forwarding issues that cause a lot of the connectivity issues that you find. And we're also trying to build for the future. If you're interested in IT at all, you know that there's been big discussions for years on IP version 6, which is supposedly the next generation protocol for the last 10 years kind of thing. All of the connections actually tunnel over commercial internet circuits. So we have some broadband connections at some different locations. We build some tunnels out to some cloud hosted boxes that are hosted in a first tier world-class data center. We have some redundancy built into those boxes, so if we lose one, the other one can take over. But then we're also keeping in mind the survivability. All of the gear, with the exception of Worcester again, at the moment can be interlinked without internet if we needed to. If we needed to, we could tie all of these repeaters together and provide service in a catastrophic scenario where we lost all 3 of the different internet networks that we have connected to this. The sites that don't have Wi-Fi links are using virtual private networking to get back to us. So this is what happens with the Worcester site. Any questions on the site connecting?
Yeah, actually, I do.
Sure, go ahead.
As far as the interconnectivity and that, I would think if I was going to design something like this, I would, in knowing that the ham radio and its history and stuff like that, and being the first and last line of defense, I would think you would work more towards interconnectivity without the actual web. Am I correct?
Well, so if you look at the diagram that we pulled up here, so Doylestown is sort of the hub of everything. So everything that is connected with a black line is an existing microwave network that does not require the internet. So Doylestown, Akron, Alliance, to John's house, and then John's house has a link to Rittman. Those are all connected today with microwave networks that if the internet goes down, those sites can all still talk to each other, no problem. The lines in gray are the links that we're working on adding. We just did an upgrade. There's now a sector dish on top of Doylestown. When we do the Rittman water tower work here, hopefully soon, there will be a direct link from the Rittman water tower over to Doylestown. I'm trying to get my house online, but I have a tree problem. I have way too many trees. And unfortunately, I can't get rid of enough trees, I think, to make that work. So that may be a non-starter, but I have a couple more ideas for that. And then we're in discussion with how we can do a microwave shot down to the Worcester location. Again, there's some tree problems to the Worcester location. So absent a massive deforestation campaign, I don't know exactly what we're going to do there. So
the only links on this diagram that rely on the internet are just the purple dotted lines there. The other ones are, you're exactly right. Those will all survive without an internet connection.
I would think that would be the way you'd want to go with that, because of the fact that, the internet could be the first thing to go down.
Yep, absolutely. And that's exactly why we did this with the microwave dishes. Yep.
Sweet.
I think we've got some pictures of some of that here a little later on, Jason, right? So,
yeah, we do. Actually, that one.
We get some of those, yep.
What kind of a cost outlay have you guys got in this so far, can I ask?
Well, I haven't tracked that, partly because I don't want to know and partly because I don't want my wife to know. I think we can all relate to that. For the microwave pieces, I was shocked. So you can do one of these setups like you have here, complete with lightning protection, the feed line, the dome cover to go over it. You're probably about $150 an endpoint.
That's not bad.
Yeah, which is, pretty reasonable. So that gives you a feel for it. And this is an example of some of the sites. So the left one, that's on the rooftop there at Spring Hill. We've got a couple of dishes there. Doylestown Tower in the middle. We're kind of lucky to have Marty on our side with this. We've got a couple of dishes on his tower. The one there at my house, NHCD East. So that's the one pointing east. The one up on top of my tower there is the next picture that's pointing over to the water tower. And then over at the water tower site, we've got a couple of those too. So each one of those dishes, about $150 by the time you put everything together. And they're fantastic. If you put the correct lightning protection on both ends, which I've learned the hard way that we have to do it on both ends. I took a couple of losses to figure that out, but they've been very reliable. No rain fade, snow fade, fog fade. They just generally work.
Wow.
And to give you an idea of some of the shots, so the Akron to Doylestown shot is 8.5 miles. Now that's line of sight. If you have a good pair of binoculars, you can literally see the other tower, but it's 8.5 miles. Between my house and Doylestown I think it's 5.2 miles is that one. And then the water tower shot is just under a mile for me.
Don't leave out Alliance.
Yeah, Alliance it's a little bit of a special case, but that one is actually a 26-mile shot with 5.8 gigahertz microwave. Now we're cheating a little. Marty used an abandoned dish on one side of that tower. It was a little bigger than normal, but I never would have believed you could get a solid link at 26 miles on 5.8 gig with, cheap equipment. But by golly, we have one. To give you a little more idea too of the infrastructure, so we looked at some of the repeater equipment. If you look at the IT equipment that's at each site, so the left picture here is what's at Doylestown, and I apologize for the cable management here, but So what you're looking at there is at the very top piece, there's 3 little boxes. Those are the power over Ethernet injectors. So those little Ubiquiti dishes are all power over Ethernet. You just run a single cable to them, and those little gadgets inject the power into the Ethernet cable. Below that, we've got a used switch that was pulled out of commercial service someplace to interconnect things. It's a little bit hard to see, but right below the switch is a MikroTik router board. It's back there in the rack mount piece, and it's a real commercial router as opposed to a home router. We do have a home router sitting there on the shelf just to provide Wi-Fi access at the site while you're there. It doesn't do anything else other than that. And then a couple of Raspberry Pis. One of those is the EchoLink controller for 14739. And then the other one's kind of an infrastructure box for us. So it does DNS and DHCP and transcoding between some of the digital modes and some things like that. So that works out there. The middle picture is at the Spring Hill site. So there again, there's a router up at the top. We've got at the bottom is another switch that runs the radio equipment, the Pis, and there's a couple security cameras there. And then sitting up on the top, you see that Motorola Radius radio and the Cantronics cam. That's the, there's an APRS node that's there at the site as well. Its name is Akron and WW8TF-2. That one is the, that's the APRS node that you see if you do that and Digipede off of that. The Rittman site, at least for the moment, is the Rittman water tower site is not quite as clean. It's, in fact, I'm surprised. Can you see the mouse in this picture? No, I don't think you can actually see the mouse in that picture, but we're doing some work on that site. We're going to replace that rack here in a bit and clean that up. But same deal, it's a router, goes up to the dishes and Raspberry Pis to tie the whole thing together.
All right, so the two technology that we've talked about, we have discussed the networking link and operating without the internet. So a couple things for operate. I'm sorry, was there a question there? Okay, so a couple things. So the two networking type technologies that we're using, one of which is ALLSTAR. So ALLSTAR is a linking technology that's based out of the VoIP world, and we'll get into that in a little bit. But it's essentially a peer-to-peer connectivity. So every repeater is its own node. You can have each repeater call any other repeater. So it's a natural peer-to-peer network. There's no central point of failure, so to speak. As we mentioned, all the repeaters on the MEGALINK use 44net IP addresses. So every quote unquote internal address is the same as external. So we don't have to do any DNS or weird directory lookups. There's no NAT. Everything just works as it is. ALLSTAR is controlled by DTMF commands. What we can do very easily is within a few minutes, take every analog FM repeater in our network, link them all together, and create one gigantic emergency network that would span 3 bands and at least 5 sites. 4 bands, I'm sorry, 6 meters, 2 meters, 70 centimeters, and 1.2 gig. Another really great feature of this technology is you can do MT63-2K over all of the VHF plus type radios. ALLSTAR passes natural audio. There's no vocoder involved, which are designed to enhance human voice, which breaks data. In the case of ALLSTAR, you can transfer MT63-2K, so you could transfer text messages and small files over the entire network as is. Just literally take your radio, hold it up to a laptop, and play and receive the MT63-2K. The other one for Pi-Star, when we developed this originally, D-Star was kind of the only game in town. It still largely is with for emergency communications. I have developed a technique to make system fusion work seamlessly across our local network as well. So now that we have that, both D-Star and System Fusion can be linked together for emergencies. The same thing applies here. Since we're using all public addressing, we don't have any weird connectivity problems. We've created our own reflector system. So if you're familiar with D-Star, it uses XRF or DCS, depending on which way you're used to using it. 330 alpha is the D-Star link. That is transcoding into System Fusion Wires X Room 83603, and it's also transcoding into DMR Talk Group 311070. So all of those modes can talk to each other. Now, only D-Star is truly cited for operations during no internet, because that's the only of these technologies that actually allows you to link repeater to repeater. We do have a method now for doing System Fusion links between the two, but that's not necessarily out of the box. We've kind of grafted that into our infrastructure. Any questions on that? All right, so as we said, ALLSTAR Link, this is a repeater controller that's based on Asterisk PBS. So if you're familiar with anything in the IT world around telephony and voice over IP, Asterisk PBS has been around for a long time. It was one of the very first sort of free software PBX systems. It's actually very robust, very capable. And Jim Dixon, who's now a Silent Key, had the idea to use the PBX functionality to be a repeater controller and to connect sites, which is essentially what a telephone network does. The brilliant thing about this is it connects FM analog sites. So we're not talking about special digital modes here. The regular analog FM, HT, mobile, base station that everyone has works perfectly fine with analog or ALLSTAR connected sites. You control it with DTMF codes. It's pretty easy to graft into basically any radio network stack. You can schedule linking. You can have ad hoc linking, and it supports EchoLink. What we found is EchoLink has been nice for some of the Sarah members who are, not necessarily mobile anymore, and they can't hit the repeater with HT. They can get in through EchoLink, and it's a good way for them to kind of stay connected to their friends. As I mentioned, everything's peer-to-peer, and you can create large meshes. So these are two existing large-scale ALLSTAR connected systems. So the one on the left is what's called the Western Intertie system or WIN system. The one on the right, and that's out west for the most part. The one on the right is the MOHOY. This is a repeater network that is all over the island of Great Britain. It's a huge repeater network that basically blankets Great Britain. The reason we're showing this is if you start out, and if I move my mouse around on this, do you guys see my mouse moving? Okay. So if I'm way down here on this little repeater and I key up, this repeater way up here will hear the same transmission, and that audio will traverse the entire mesh from wherever you are in almost real time. The lag is less than a second. And the reason for that, it's based in telephone protocols, which have a real-time component to them. It's really an incredibly nice system. John, you want to talk about how we graph the ALLSTAR into some of the controllers?
Yeah, there's a couple of ways we've done this. So this is a block diagram of the 14739 Sarah machine. And so on the left side, if you start there, it's a traditional repeater radio. It's the Bridgecom BCR50 repeater. And then we broke that into the receiver and transmit boards. We weren't real happy with the squelch board in the Bridgecom, the way the squelch operated. And frankly, not real happy with the way the PL worked in the Bridgecom either. Other than that, it's been a fantastic repeater. So we added an old school Micor squelch board to the outboard for that, and then a ComSpec PL board outside of that. And those, we would have done that whether we did ALLSTAR or not. I think we would have stuck those in there to augment the repeater. Those, so in a traditional repeater, if you go to the right, you would normally have an SCOM or a RLC or, one of the other big brands of controllers. What we have is a little, it's a sound card essentially. It's an external sound card that then plugs into the Raspberry Pi. And the sound card has some extra pins run on it for digital I/O. So it does COS and PL detection and PTT out. Then that goes over to the Raspberry Pi to actually do the brains and put the thing on the network, and everything from timeout timers to courtesy tones to identifications, club announcements, all that stuff comes out of the Raspberry Pi, mostly as cron jobs and other things as part of the ALLSTAR system. 5317, so this is Marty's big 6-meter repeater. That's been up for years and years and years. He's got a couple of GE Master radios, and he's running a Cat 1000, very traditional repeater controller on that still runs the main repeater. What we did was grafted into another radio port on that controller. A lot of repeater controllers have a port on them for a remote base to plug in. So instead of plugging a radio in, we plugged in the audio interface board and then plugged that into the Raspberry Pi. So in addition to all the things that as a repeater has coverage to originally, it now also can get ALLSTAR and EchoLink service through the Raspberry Pi over on the right. That's a little different twist on how to connect. So either way, we can graft it on or onto an existing controller, or the Pi can be the controller by itself. Jason?
Yeah. So some pros and cons of ALLSTAR. It does use standard analog FM, so you don't need any special radios and no particular radio skills with some of the digital modes. You can do repeater-to-repeater linking without the need of central network or reflectors. It's easy to script announcements, clock alerts, weather alerts, anything you want to put. We stream Newsline on the Sarah machine. EchoLink is an option if you want to do EchoLink, and like we mentioned, you can do the data modes of MT63. The con is if you've seen some of the digital hotspots like Pi-Star or OpenSpot, the user interface is not nearly as polished for people who aren't familiar with Linux. So you do have to get a little bit familiar with Linux. And another con is EchoLink as an option. So it's a pro and it's also a con. EchoLink is really nice for connectivity. EchoLink is also very frustrating to operate, has a lot of problems, and causes some really strange latency issues with repeaters. If you're looking to graft ALLSTAR onto a repeater, basically what you're looking for here is a Raspberry Pi 3B. You need a good micro SD card, and I emphasize good because you are going to do a lot of writes to this card. You need the USB audio adapter. We had been using the DMK URIX things, but I think we were largely switching to the Masters Communication RA40 boards. They're a little bit cheaper, and they have really good audio. They're as good or better than the DMK boxes. So out the door, except for cabling and some of the other pieces you need, you're looking about $122. There's URI cables has many pre-made cables if you'd like, or creating a custom cables is pretty simple. Almost all repeaters and radios can be lightly modified to connect to this. So before we go on, are there any questions on the FM ALLSTAR linking? And I'm going to throw that to John because I got to go grab a battery for my headset here before before the battery runs out.
Yep, absolutely.
John, I had a question about the microwave links. What size dishes are you using on those?
Those are the 400 millimeter.
Okay.
So the ones we're using, and all but one of the links now is the M5. I think it's the M5-400. It's a power beam series.
Are those the same size as the satellite TV? What's it called? I can't remember the name of the commercial, the service.
Like
DirecTV.
Dish.
Yeah,
yeah.
It's actually a little bit smaller than that.
Okay.
They're probably maybe a foot and a half, 14, 15 inches across.
So they're not likely to be confused. They're very likely to be confused for consumer grade electronics and not really something that's.
Oh yeah, absolutely. Yeah, and they're pretty lightweight. And we've even found, in a couple of the cases, we've put them up without having the plastic radome over the front of them, and they survive quite well. Even up on a tower, on the Doylestown Tower, where the one is up, I don't know, probably 150 feet. We've got the little plastic radome that snaps over the front of that, just to keep the rain and weather and stuff from slapping the radio up.
John Frank Tompkins, W8EZT. I'm the radio officer here. What's the practicality and feasibility of connecting two? Right now we have a ARCOM controller and two GE Master 2 repeaters, VHF and a UHF in a configuration to connect that to the ALLSTAR setup and network.
Do you have a third radio port on the ARCOM?
Yes, we do. Right now it's our control receiver.
Ah, gotcha. Okay, that'd be the ticket. That's pretty close to what we did with 5317. And also the 444.2 is the same way. It's got a traditional controller, and then the Raspberry Pi is plugged into that extra radio port. Now, and you mentioned the control receivers, so something to think about. When you dig into the FCC requirements, the ability to shut the repeater off remotely that you usually use a control receiver for, you can meet that requirement with the Raspberry Pi if it's internet accessible. So if you allow that to pass tones through to the repeater controller itself, that's an option even if you wanted to replace the control receiver that's on that radio port.
Okay, appreciate that. Thank you. Before this is over, I'd definitely like to get some contact information for the two of you.
Yeah, absolutely. Yep. And I was thinking here, Frank, you could probably even put the Pi in parallel with the control receiver. Since it's a receiver only. If you're careful about not loading the audio paths too much, I bet you could run on both at the same time off that port.
Okay. I had talked with the other gentleman, Bruce, AKB, who I don't know if he's in here or not tonight, but he had, we had talked about perhaps a usurp ability, so the control receiver could step in and override the third port, but otherwise it would be open to the ALLSTAR system. So very good. This is very, very good.
Yeah, I think that'd work out well. And to give you an example of something that's like that, so Marty's 444.2 repeater, we run the ALLSTAR controller in as an additional radio port into that. The repeater itself is still controlled by the regular controller. But the nice thing about that is you have the option of which real repeater that you connect to the ALLSTAR. So, for example, if you wanted to leave 147.27 connected all the time to ALLSTAR and then only do UHF when you want it, you can just map those ports together inside the ARCOM and voila, they're connected. Or you could connect all of them together if you wanted to. So,
very good. Excellent.
Lots of options. Yep.
Any other questions on the analog before we kind of do? I know we're kind of running up against the time here, but I wanted to dive into some of the Pi-Star stuff real quick. Any questions on the analog pieces? All right, so a lot of the other ones, we talked about using an MMDVM board. We're really using the Pi-Star system for these. Pi-Star is a really nice project that interfaces with a variety of the different MMDVM type digital radio boards. Our personal favorite is the repeater builder STM32. That has been an absolute rock solid modem board. We've used that in a number of deployments. It has been just fantastic. That system supports D-Star, DMR, System Fusion, P25, which we have tested. I don't know if anyone knows Eric WDHKNL. He has a P25 radio that we tested the system with, and NXDN. Now, we don't know anyone with an NXDN radio, but if someone has one, we'd be interested in someone trying it.
Right.
Pi-Star is a pretty easy to use system, and it's pretty easy to deploy. It's well documented. It has a fairly user-friendly interface, even though it is Linux under the covers. And one of the things that we've spent a lot of time working on is transcode capability. So our systems now can talk between all three digital modes. System Fusion, DMR, and D-Star are all equal partners in being able to talk to one another. If anyone's in range of any of the machines we listed tonight, Mondays at 8 o'clock, there is the Wayne County ARESnet, which is called the Bolo Net. It's carried simultaneously on all three modes. Worcester is set for DMR. Sarah, the 70 centimeter machine in Doylestown, does System Fusion, and the machines in Akron and Rittman do D-Star. And it works pretty well. Now that the unit has stopped overheating. It's actually temporarily at my house again because we figured out that we need to add a fan to the vocoder chips because they're getting too hot. So it's back at my house in the air conditioning. John, why don't you go ahead and talk about how we grafted this onto the TKR?
Yep, sure. So this block diagram you see looks an awful lot like the way we do ALLSTAR. The only difference is, instead of taking analog audio off the board, we're pulling discriminator audio off into the STM32 modem board, and then sending non-preemphasis audio into the transmitter. So we've taken a TKR850, which is a, probably circa 1995 Kenwood repeater that didn't know anything about digital, plugged into the port on the back of it with this STM32 DVM, and then plug that into a Pi running Pi-Star, and boom, you have a multi-mode digital repeater. And there's some tweaks involved in that. There's, some audio levels have to be just right, that sort of thing. But we didn't have to do any modifications to the repeater itself. It's make the cables, tweak the levels, and boom, you're on.
Yeah, and then as you saw in the pictures, we've done that with, so John and I have been for the last couple of years scouring every Hamfest and Hamvention for every ham band capable Radius GM300 and MaxTrack radio that we can get our hands on for, let me see, the cheapest one I've gotten was $7. And then the most expensive one, I think we've paid $30 or $40 for.
Yep.
You can find them laying around at pretty much any Hamfest. The biggest thing about those is getting a DOS box set up with the right version of the Motorola. I'm blanking on what the name of that software is.
CPS, yeah.
Yeah, their CPS software. But there's a lot of people building them now with. Is it the CDMs, the ones that replace the radiuses? There's a lot of people
the CDM
with
750s and yep.
Yeah, and I personally have recently developed an interest in ripping the guts out of Yaesu DR1Xs and replacing them with useful pieces. I have a whole series of blog posts about that on ww8tf.club. So some pros and cons for the Pi-Star setup. For the pros, it's very easy to deploy with basic computer skills. It's pretty formulaic to flash the card, stick it in. They've done a really nice job on the interface, I think, to get that deployed. Digital mode. This is really important. Digital modes don't require the COS/COR detection capability. That's important for two reasons. One is repeaters with bad or broken squelches can be used. So DR1Xs, for example, the original versions have some pretty famously terrible squelches. Some of the other ones where, you know, the squelch is really wide, it doesn't, or really narrow, it doesn't matter because you're not using that decode signaling. You're just taking the raw audio right off of the receive radio. And then the modem itself decides when it has seen the protocol it's looking for. The other nice thing is for home brewing, you're not limited to radios that expose a COS pin. So while the radiuses and max tracks are really nice from a nice rugged radio, you can deploy as any type of radio. I had a DR620 that I recently gifted to someone here. And for a long time, I had a test repeater at my house that was using that as the, it was either the transmit or the receive radio. I can't remember which one I had. I think it has the receive radio. Because you basically can turn the squelch all the way off, and you don't need the COS pin to signal the decode. You can basically hook it up to any radio where you can just, you know, back the squelch off completely and listen to the audio. So it does scale from micro simplex Hawk spots to full repeaters. You know, the 442.275 is a pretty high profile machine that you can get to pretty far away. And it's the same setup that we're using on a, I built a little tiny self-made Pi-Star repeater or simplex node for my house that's basically a Pi with a Pi hat grafted on it that runs, I think, at 100 milliwatts. Same system, very robust for both. Some of the cons of this setup is the modes can't talk to each other without transcoding. We've done it. It's not easy, and that's a whole other presentation that maybe we'll give someday. Some of the modes don't function well without their supporting networking, and basically that's looking at you, DMR. DMR does not work well at all when it does not have its internet network. If you've listened to some of the nets that go on when they have a lot of participants and someone has an internet glitch, you can see pretty quickly how that goes south. The other con to the digital modes is that you can't do data transfer. So like we talked about, you can do MT63.2K over an ALLSTAR link. All of the digital modes are optimized for voice, and the exception is something called DRATs, but that's not very common. So for all practical purposes, that's not useful. The vocoders are designed for audio, for improving human voice over digital, which works really well for digital voice audio and corrupts any digital mode that you want to send over the networks. If you want to build a Pi-Star, again, you know, you're looking about 166 bucks. The big cost here is the DVM duplex capable modem. The STM32 DVM has worked really well. There are some others out there. It's not the only option, but we've had a lot of success with that one. You can get pre-made cables for Bridgecoms, Yaesus, Kenwoods, Motorola's. Otherwise, you know, you're looking at a D-sub D9 connection with 4 wires. It's pretty easy to solder up and test. There's no complications to any of those. Pretty much all repeaters, again, with some light modifications, can be connected to that. I think you said you use GE Master 2s, so you're not using Yaesu DR1Xs. Is that correct?
Well, we that is correct. As far as the official club, there's a side organization that some time ago purchased a DR1. I've not had a chance to go back and check to see if it's the original one or if it's been back to the factory, but we may have access to a DR1.
Right. So if you have a DR1X, if you check out ww8tf.club, I posted some very detailed instructions on how to fix it so that it largely works reasonably well. but it has to be an original, a quote unquote original DR1X. So there's some examples. It basically has to be firmware 1.0 or 1.1. Any of the letter versions is acceptable. You'll have to do a firmware upgrade if you don't have the FM wide deviation mode, but that's pretty trivial. If it did go back to the factory, it's what's called the FR version, or the DR2X. You cannot use those for outboard controller work for digital modes. The reason is you can't bypass the DSP, which is optimized for voice, and will ruin any of the digital modes other than, System Fusion if you're doing it natively with the inboard AMS controller. But if you try to do an outboard controller, the DSP ruins the audio.
I'll have to check on that and get back to you, Pat, with that information. Thanks.
Yeah, if it's still an old one, hang on to it and don't send it back.
Yeah,
you have a piece of gold there. Yeah,
as a matter of fact, I have an eBay alert that fires off whenever anyone posts a DR1X for sale. I actually have the guts of one that I believe I have the rest of the parts to fix coming. That's going to arrive on Monday.
Actually,
so
I've actually got the manual for that DR1X. It is actually a 1X, and it has not been back to the factory that I know of.
Nice.
Then you're in good shape. You could use that for a number of things. You can do it with Pi-Star, or I have some schematics on if you want to actually graft in a usable squelch board and a tone coder to connect to ALLSTAR. We have plans for both.
All right, as we talk this over, Pat, we'll have to keep that in mind as one of many options.
I agree.
So some questions to ponder, and I mean this isn't a Q&A necessarily, but we're just kind of throwing these out there for things. Is who are your users when you're trying to decide between these kind of things? Are you trying to support a huge installed FM analog base? And a lot of people are. That might lend you to ALLSTAR. Do you want people to get involved in some of the digital modes, or can you do both? Right? What radios do they already have? Again, that helps you pick which modes you want to focus on. For example, when we were working with the Worcester guys, there was a lot of DMR. And so we kind of focused heavily on DMR because that's what they wanted to get into. Some of the question is what's your core group going to be using and able to support? This isn't going to be the work of one person. If you want to support any reasonable number of people, you kind of want to have a core group of people, especially with the digital modes. ALLSTAR is quite a bit easier from an analog FM perspective, but especially if you're going to go digital, who's your core group, and what's your goals in converting? Are you looking to do ALLSTAR linking with regular FM? Do you want to get people involved in some of the like the Ohio DMR net, or there's a Sunday night net that links D-Star and System Fusion? What are the goals and what you're picking to do? How does this play into retaining and attracting hams? There's a lot of hams who are getting into it because they read about digital radios. Is that something that your users and your members are interested in? And then another question is how concerned are you with survivability and MCOM? Some groups are really interested in that. Other groups are more experimental and less interested in that. So you got to talk about what your risk tolerances are and how much you want to invest in what we'll call the survivability of your upstream. We talked about the internet connections. If you want to be all DMR, that's great. You better have a really good internet connection and understand what the implications of that are. So how we've done it, a lot of it is education. We've met a lot with the clubs that we've done this with. We've done presentations. We've done some hands-on radio. At one point, John, I think, programmed about a dozen digital radios in one night at a meeting. That is not necessarily a process that we recommend, but it did get things going. If your user base, especially if you're doing digital, the club pick a standard and have a basic radio recommendation. So for example, if you want to get into digital, one of the things might be to do a system fusion radio, because there's a couple different price points for those radios. You can get the FT70, which is less expensive, all the way up to the FTM 440, which is about $500. Deploy the system. And then you're going to have to educate your group again, because in the intervening time from when you decided to do it and then when you deployed it, everyone forgot what you taught them. So you're going to have to educate again. Consider holding a programming clinic. Even if it's an analog radio, you can program in the repeater frequencies, DTMF macros, some of those things in radios, which makes it really nice. If you're doing programmable radios, especially digital and absolutely especially DMR, make sure you develop programs and code plugs for your group. I think John and I have done 7 or 8 different radios now for Sarah that all have consistent naming, consistent terms, and consistent setup, especially for DMR. That really lowers the barrier of entry for people getting into this. And this is just kind of a screenshot. This is sort of the work, actually Doug Hunter, KE8JNH, sort of developed the idea, and then we kind of helped him implement it. But basically for example, they chose DMR, they standardized on DMR, and they basically came up with code plugs that have consistent naming for everything. And really this comes down to standardization, education, and practice. And that's about it. I recognize that we kind of sprinted to the finish there. So there's some references, and what questions are out there? I see Anthony's got his hand up.
2 questions. The first question is, it looks like from the one diagram that if you wanted to run a radio without a traditional repeater controller, you could set up that with the ALLSTAR. Can you also do that with the Pi-Star?
Mm-hmm.
Yeah, that's this diagram.
Okay.
Yep. For Pi-Star has to be the repeater controller. You can't graft Pi-Star onto a remote base. It has to be the repeater controller.
Okay.
For ALLSTAR, you can do it either way. It can be the controller, or it can be a remote base off the controller.
Okay. And if our main concern was to maintain analog FM capability, is there a difference in Pi-Star versus ALLSTAR as having that as one of the main functions?
Pi-Star is digital only, and ALLSTAR is analog only.
Okay, so
if you're interested in analog only, you're looking at an ALLSTAR deployment.
Now, well, how does with the 6-meter radio that is being set up, you're running that with a Pi-Star, but he's still using it as an analog radio. So, oh no, you're using ALLSTAR with that. You're not using Pi-Star with that.
Yeah,
okay,
that's
I'm sorry.
ALLSTAR.
Okay, I'm sorry. I thought that was a Pi-Star attached to that. Okay.
And I think this diagram is pretty close to what Jim had mentioned that you have there on the Falls machines, right? It's the G Master radios, and you've got an RCOM instead of a Cat 1000, but it's shockingly similar to this setup.
Yes, that's correct.
I think they're the same vintage of initiation.
Yep. And it works fantastic. It's it's the same thing as anything else with a repeater. You have to tweak the audio levels to get them so they sound right, and keep your cables short, and maybe throw a ferrite choke or 2 on, and you're in business.
Yeah, that's why we actually have started replacing the DMKs with the Masters Communication RA40s. They have really nice trimmer pots on the audio, transmit and receive. The DMK basically has 2 audio levels. There's an unamplified and an amplified. The RA40s actually have adjustment pots, which makes it really nice to really dial in the audio for consistent levels.
And there's digital adjustments too, so you can SSH into the Pi and tweak them a little bit, but it's nice to have that pot to at least get you in the right ballpark.
The Wi-Fi interconnection would support more than one radio. So let's say we wanted to keep the 440 and the 2 meter through separate controllers, and let's say we set one up as a digital and one as a analog only.
Yep.
Would we want one Wi-Fi would be enough bandwidth for it?
Mm-hmm. Oh, absolutely. Yep.
Oh yeah.
Yeah. What you'll find, Anthony, is the bandwidth on the ALLSTAR connection depends on which codec you're using, but it's, I don't know, 15 kilobits per second, 20 kilobits per second. It's tiny.
So they're not bad.
And
okay.
the digital modes are pretty close to that. They're 20, 25 kilobits per second at the most. So, yep, no problem at all. In fact, some of the sites we've got webcam, and Spring Hill is a good example. So we've got 2 cameras. The controller, the APRS node is sending data back to us through there. And we've got 1, 2, 3, 4 repeaters all running on it as well. So, oh, that's right. Yeah, 5. Yeah, sorry. So it's all off of one set of those dishes coming back.
And it's in no way saturated. I mean, it's
Right.
not even close to being consumed.
John, Jason, Frank again, W8EZT. From our repeater site on the roof of a building downtown Cuyahoga Falls, I believe we have direct line of sight with Spring Hill. It sounds to me like this would make it eligible for a one of those ubiquity dish links, which then would basically make the internet just not redundant, but a backup system. Is that correct?
Yeah, that actually would be great. I think we need to talk, Jim. We might be able to work something out and do some mutual back scratching there. I like that.
One other question: how much of your network at this point has emergency power, either battery or some kind of generator or something? So if commercial power fails, it's running. It stays running.
Let me think. So the Spring Hill site, the building is on a generator, so we'd have a brief outage, and then that comes back. The Doylestown site, we've got the IT equipment is on a traditional UPS. I think it's a 900 watt, one of the little APC UPSs that runs the IT gear, and then each repeater has batteries on it. The ones at the Rittman water tower in my house are not battery backed up yet. So it's about half and half.
We're moving towards being able to have full battery backup. There's still some work to do, but that's the direction we've been moving right now. And I just want to make sure anything we do in this direction is consistent with that approach.
Yeah.
We're also the Skywarn primary repeater for Summit County at this point.
Gotcha. Yep. Yeah, you'd be in good shape. The Spring Hill site, and then it actually picks its internet up back at the Doylestown site, which is also battery backed up. So, has on the equipment. So you'd be good there. What I would probably do, Frank, is on the IT gear, it's tough to beat those little consumer UPSs. For $50 to $100, you get a gadget that you plug your dishes and your router and everything into it, and you're done. Then you don't have to monkey around with converting 12 volt DC to 24 volt PoE and all that stuff. You just plug it in and it's happy.
Yeah, and it's important to note that a Raspberry Pi and a Ubiquiti dish are very small power consumers. Mm-hmm. They're going to be a fraction of what your transmit radio, and if you have an amp, I mean, it's going to be a fraction of it's going to be a tiny fraction of that power draw.
Exactly.
Ubiquiti dishes, I think, are, is it 12.2 watts, I think, off the PoE port?
Something like that, yeah.
I think it's something like that. It's pretty small. And then the Pi, it's like they're less than 2 amps at 5 volts. So, you're looking, 15 watts or thereabouts.
No question about it. All of that's low power. The big power eaters, as you say, are the older Master 2s that we have.
Yep. Yeah, your receiver probably uses more than all the IT equipment combined, but that's how you get it.
Yeah, and the other thing to keep in mind too, especially if you're looking at sticking with analog FM, even if you lost the internet connectivity, that's not going to take away any of your local repeat functionality. You know, so absolute catastrophic case, there's a regional massive blackout, right? And you know,
That's never happened.
yeah. You know, John and I do both work for the power company, right?
No, I did not.
Yeah, it's all right, Frank. We hang our head in shame quite a bit, so that's all right.
Or the better question is ask everyone who works in IT how many generators they have at their house. But no, in all seriousness, I mean, if you know, let's just say Spring Hill lost power and for some reason didn't come back, the generator failed or whatever reason, you know, at the worst case, you're limited to your local site repeating again until the Spring Hill came up.
Mm-hmm.
So you know, you don't lose that functionality. And you gain quite a bit for the the 99+% cases, everything's working fine. So you gain a lot of functionality.
Got it. One last question, somewhat off the base so far. We may have access to another repeater, Kenwood TKR, I believe it was 540. Do you have any experience with those in your network right now?
No, I haven't used one of those yet. No.
Okay.
My guess would be, Frank, that the worst case, we had what was the old? It was a TKR 820.
The 820. That was the 820.
Yeah.
Okay.
You can generally graft these things onto there. The worst case would be if you don't have really flat discriminator audio that comes out the port on the back. The worst case is you open up the receiver and you may have to tap in there to pull the flat discriminator audio off.
Okay.
Same for the transmitter, but it's, you know, as surgery goes, it's pretty easy.
Right. Okay. All right. Thank you.
Mm-hmm.
Jason, before I forget, can you hand back the host to me so I don't, because I ran into a problem with the recording one time with not having the host at the end.
Sure.
Mm-hmm.
Okay.
Yep. Do you want me to do that now? Or
yeah, why don't you go ahead and do that now? If you need
right.
to share the screen again, I can bring it up because I have the slide presentation here. By the way, the new presentation is on the website. So if anyone wants to see the presentation again, it'll be on the website. And this recording will be on the YouTube channel by tomorrow morning because I have to do a little bit of editing on it, and it'll be there by tomorrow morning.
Nice.
Okay.
Hey, Scott, curious, so you're saying that everything goes from all the sites on the microwave back to one to get into the internet then?
Well, we have two different internet connections, so we can go out of the Doylestown site and then also out of my house.
And Alliance.
Sites,
and Alliance, we have 3.
And Alliance too, yeah, that's right. So, and the way we've got the routing set up, the Doylestown site is primary. It's the closest and the best. And then if we lose that, my site is the failover site for those. Yep.
So when we're looking at the webcams, they're going back to a different site and writing back with all the other things they're writing back to the site.
Yep. Yeah, we just push those up to a web server, but it's all over those microwave links. Yep.
Yeah, and that kind of goes back to one of the reasons why we're not using the RDEN stuff. You know, we're doing a little bit of back scratching with Marty for some of his other endeavors. So, you know, we're using, you know, the commercial pieces of that so that we can kind of, you know, we want to make ourselves a good partner, right? So that's some of the reasons why we're using that commercial equipment.
Sort of like the olden days back when they had that wide area network on the west side of Ohio down to Tennessee.
Mm-hmm. Yep, the old Faranet, I think, right?
Yeah.
Anything else we can answer for anybody?
I have a question. Was the 444.2 megahertz repeater off the air for a while?
Mm-hmm.
It blew up.
Yep, it blew up. It died, and Marty was on vacation, and then we had a couple of complications getting up to the site a little bit COVID related and a couple other things too. But yeah, got up there two weekends ago. I think we made a mission up there and got that replaced. So
Okay, so is
yeah,
it
the power.
So on Sunday evenings, is it linked to the 6-meter repeater?
Nope, we took that off. The 6-meter net has changed around a little bit, so we've taken that link off, and then the pajama net runs there on 444.2 now at the same time.
Okay, thanks.
Yep.
This is Frank again. I'm going to hazard a guess that we're going to have some discussions amongst interested club members on this, and the officers, and Bruce, the gentleman who works with me to do the controller programming, and then probably come back and go back and forth with you guys with some questions, and then maybe formulate a plan and go from there. So we will be back in touch, obviously. As I said, I wanted to get some contact information either before this, or if you just send me your email at radioofficer@cfarc.org, that'd be great.
Yeah, absolutely.
Yeah, absolutely. Awesome.
Well, thank you both for doing the wonderful presentation tonight. Get a round of applause from everyone.
Oh, thanks.
Thanks, guys.
Yeah, very nice job. Very informative.
Thanks.
Thank you for being
I'm going to go ahead and stop the recording.